I want to welcome everybody to coming out to the GPUG. This is our June meetup. We're really happy and excited to be welcoming back Jonathan Reinink. He's going to be talking about database performance in Laravel and recently just released a video course called Eloquent Performance Patterns. So he's here tonight to talk to us about how we can get the most out of our database in our Laravel applications. I'm going to hand it over to you, Jonathan. So Jonathan, take us away.
Good evening, everyone. Thanks for having me at the GPUG. I've given a number of database performance talks in the past, and I was thinking about tonight and kind of wondering what content I should share, because I feel like I've kind of have my common go-to things and patterns that I like to share, but I kind of wanted to do something a little bit different tonight. Basically went through my course and pulled out a bunch of things and try to mash a few lessons from my course kind of into one lesson. So I've got a bunch of stuff to go through, and basically I'm just going to live code this little demo app that I've created, and we're going to just make a bunch of changes and kind of identify performance issues and fix those performance issues. If you've ever seen one of my talks in the past, that's kind of the way I like to work through it. Okay, so this is a little demo app. Could be like a CRM or something like that. And it has a users page, and the users page lists all the users in the app. They're paginated. There's 15 results per page. I'm just using simple pagination right now. And the page lists the user's name, their company, and their birthday. And the name there's a first and last name column. I'll just show you the database here for a second. Okay, let me just close some of this. We got a companies table. The companies table has 1,000 records in it. And then there is a users table as well, and that has 50,000 records in it. So there's 50,000 users and 1,000 companies. So every user belongs to one company. Simple belongs to relationship there. So hopefully this is kind of enough data for us to identify any potential performance issues as we work through this. So let's start off like real simple. So kind of the one thing that I've really been talking a lot about over the years is just the importance of tracking the various metrics that relate to your database and your database queries. I really think that unless you're using something to tell you how many queries you're running, how fast your queries are running, how much data you're pulling from the database, how much memory usage you're using, unless you're doing something to track that kind of stuff, you're really flying blind, and you're going to be much more likely to run into performance issues when you move your app to production than if you track that stuff while you're in development. So I use a tool. This is something anybody who's followed me for any time knows that I like using the Laravel debug bar for this, which is basically just a little inline info sort of window, sort of like the Chrome Dev Tools, that kind of pops up and gives you a bunch of information about your request. In particular, queries, how many queries are running, how fast they're running, how many models you're loading from the database, how much memory you're using, and how long the page took to load. So to kind of get us going here, let's start kind of simple. And I've started by introducing an N+1 issue in this particular demo app. So we're loading all the companies for all the users. And you can see here, if we look under the queries tab, that we are running the same database query for the companies over and over and over 15 times, which is obviously an indication that we have an N+1 issue. So this is a pretty simple problem. You've probably run into this before. So the way to solve that is to just correct it by eager loading the company relationship. So I'm got a users controller set up, which is for this particular page. And we'll just say with the company. And now if we hit reload here, we're back down to 2 database queries the way we want it to, right? So it's going to load our users, and then it's going to load the companies for those users. And right now it's just because one company has 50 users, we're only getting one company back because it's just listing them in the order that they were entered into the database. Little fun fact, if you're using the simple paginator, the way Laravel knows that there's more content on the next page is it actually selects one more record than what you're asking for. So by default, the Laravel pagination will only grab 15 records, but you can see down here in this database query, have a limit of 16. So Laravel still just returns 15 records back to you when you display it on the page, but it grabs 16 from the database, basically just as a way of knowing, yeah, there's more after this page. So kind of a clever little solution that Laravel uses to make the simple paginator work. Okay, so now that we're warmed up here a little, try something a little bit slightly more complicated. What if we wanted to order the users by their name? So as I mentioned, this table has two columns. I think I mentioned it has a first name and a last name column. So what we're going to do here is we're going to update this page to order these users first by their last name and then by their first name. So that's a kind of a common way to order a name. So let's just go back to our users controller here, and let's just do an order by. We'll do the last name first, and then we'll do the first name. And if we hit refresh, sure enough, that works. It's ordering by last name first, and you can see the first name second. If we look at our database queries here, select star from users, order by last name, and then the first name is setting. So that query is taking about 2.4 milliseconds to run, which is not the speed that I wanted it to run at because I haven't reseeded my database. So I'm not going to be able to show you any performance issues if I don't start with a fresh database here. So let me do that, migrate fresh, and let's reseed this. And this is going to take a second because 1,000 companies and 50,000 users. So I'll show you the seeder that I'm running here. I'm just running a factory, getting 1,000 companies. And then for each one of those, I'm generating 50 users. Okay. So that's pretty normal database seeder stuff. Maybe you wouldn't normally generate this many records, but when you're trying to figure out if there's any performance issues, it's good to have lots of data in the database. Okay, let's see if we're done here. Yep.
While we're here, while we're waiting for this to finish, we do have a question just about the debug bar. Just wondering where it comes from. I can handle that if you like, or if you'd like to answer it.
Yeah, I don't mind. Sure. It's so it's called the Laravel debug bar, put out by a gentleman named Barry, and it's available on GitHub. And yeah, I've been using this thing for years. So basically, to install it, you just, I think there's installation, just Composer require that package and install it dev only. Typically, you'd only want it in your dev environment because it exposes a lot of information that you wouldn't want visible in production. It does only show up if app debug is set to true anyway. It's pretty easy to get installed, actually. And if you have it installed in your app already, but you haven't updated it in a while, definitely update it, because recently Barry and some others did a nice little facelift to it and updated the design a little bit and added, and this models tab is now enabled by default. That's actually something I helped add to the library, I think last year at some point. So previously you had to enable that manually, but now it's enabled by default. So, okay. I think we should be good here. Yeah. All right. All right. So hopefully this is slower now. There we go. Oh, so much my big reveal here of how fast it's going to be. The giveaway is it's going to be about 2.5 milliseconds. But okay, so we're at 55 milliseconds right now, right? And we just ordered by the last name and the first name. So basically 55 milliseconds isn't bad, really. Anytime a query or a page is taking, less than 100 milliseconds to load, that's pretty good. But I think there's easy wins sometimes. So when I see 55 milliseconds for such a simple database query, I think there's improvements that can be had there. So we'll add an index for the last name and the first name. Okay, let's go back, add name indexes to users. Okay, so then we'll just say table index. So we'll create a new index on the users table for the last name and for the first name. And then we'll create the down migrations as well. And to be honest, I actually don't normally make down migrations, but we're going to be making some changes, and having the down migrations is just going to make that easier. So drop index and users last name index. Okay. You know what I'm going to do? I'm going to just make sure my linter's running here so that it identifies any issues. And that's exactly what I'm looking to do. Okay. So now let's run the migrations, PHP artisan migrate to actually run the migrations. And now if we go back to the browser and we hit refresh, it literally didn't make any difference. And this is, I think, a problem that people run into, and they're like, oh, what, I just added indexes to the two columns I'm sorting by, the last name and the first name, but it literally had no impact on my query at all. In fact, it almost seems like it's worse. So what I'll often do in a situation like this is I'll copy the query that, in Laravel, the Laravel debug bar makes it super easy to see the query and copy it. And then I'll jump into Table Plus and I'll just run an explain on this. So I'll just explain, and then I'm pasting the query and hit run. And this is a little bit confusing at first. And it's, the whole explain tool is amazing, but you kind of got to learn over time how to read it and what the different things mean. But I'll start by looking over here. So if you look in the extra column here, you can see that it's using file sort for sorting. And that's not good. That basically means that it was unable to use any sort of index in order to do the sorting. So even though we just added a last name and a first name index, it still used file sort. So, and that's slow. But what's interesting here is if we remove one of these columns and we just sort by the last name and we run it again, you can see it's not ordering using file sort anymore. It's now using, if we look in the key column here, it's now using the last name index because we're ordering by the last name, but not the first name. And if we reverse that and get rid of the last name and run it again, you can see that it's now able to use the first name index. So individually, it's able to use the indexes on their own, but together it's unable to use them. And in these situations, a great solution is to use a compound index. So a compound index includes more than one column. So let me just show you what that looks like. We'll create an index and we'll say last name and then first name. And we'll just pass that through as an array. And then down here, the way you would handle the drop index is you would just say, it's just Laravel just groups or like joins the names of the column together. So it'll be user, last name, first name, index. Okay. And now actually I gotta be careful here. I gotta roll this back before I do that. So let me roll that back. PHP artisan migrate, roll back to get rid of the old ones. Okay, now I can update that. And now if we run PHP artisan migrate again, migrate, spell it right. Okay, now we've added the new compound index. And if we go back to table plus here, and we go to the users table and we see in our structure for the table, you can see now that we have a user's last name, first name index, and that's on two columns, the last name and the first name column. And if we run this here now, again, the explain again, you can see that it's now working. We're now getting our user's last name, first name index, and we're not getting any file sorting happening. And if we go back to the browser and we hit refresh, now we're back down to less than 2 milliseconds. So 60 seconds or whatever, 55 seconds doesn't seem that bad, but 2 milliseconds is really, really fast. So that's a nice little win. If you have a page in your application that does this kind of sorting, multi-column sorting, which I find is extremely common, then a compound index can go a long way to kind of improving the performance of that. A couple little gotchas around here. If we go back to our controller and we sort by the first name first and then the last name, we're right back up to 53 milliseconds. So that's something to keep in mind. It's literally the order of your compound index when you're doing ordering matters. So that's why I was very intentional about putting the last name first before the first name. Okay, so that's one thing. So let's roll on to the next thing here. I want to talk a little bit about memory usage. So one of the trickiest things that basically what I ran into in a large project that I was working on, we had these pages that were running really, really slowly, and we couldn't figure out exactly why they were running so slowly at first because we kind of always assumed that it was just our database queries that were the issue. The problem on these pages is that the database queries were actually so fast. Like, why are these pages taking so long? And what I started to realize is it wasn't the speed of the database query that was the issue. It was how much data that was being transferred from the database to the web server after the query ran. So imagine if you have, a lot of times in modern hosting, PHP hosting setups, you'll have your database on a different server than your web servers, because often maybe you'll have multiple web servers, maybe you have a load balancer and different things like that. So the database servers over here and the web servers are over here. So you could go to the table that has 1 million records and you can say, well, you run the database query, say, give me all the data from this table. And that query, because it's really quite a simple query, might run extremely fast. It might take just a few milliseconds to run. But if that table has a ton of data, all that data now needs to be passed over the wire, right? Like from literally one physical machine to another physical machine over the internet. And that can be a very slow process. And then it's not only the time that it takes to just physically move that data from one location to the next, it's also the time that it then takes Laravel and it takes PHP to work through and crank through that data and convert it from whatever the database gives back to eloquent models and kind of hydrate it all and all that stuff that goes on kind of behind the scenes with Laravel and Eloquent. So what I started to realize is that we're pulling much too much data back from the database, but it wasn't like super easy to identify at first. One metric that you can look at to kind of get a bit of an idea of this is this memory usage metric. So we can see here that right now Laravel is using about 4 megabytes of memory, which doesn't seem that high, seems kind of innocent enough. And on my system, Laravel just uses about, I think, without pulling any data back, really, uses about 3.5 megabytes of memory. So it's not always a great metric because even if you introduce an issue, this number may not jump up that much higher. And that's really why I like the models tab. So this is something I helped get it added to the Laravel debug bar. And it's really, really useful. It gives you an outline of exactly how many models have been pulled back from the database, so that you know exactly how much data you're getting. And if it looks like it's too high, you can say, well, maybe I got to figure out what's going wrong there. So again, even though this page is showing 15 records, Laravel behind the scenes is grabbing that extra one for the simple pagination to see if there's more records for the next page. So we're getting 16 companies and 16 users. Okay, so let me, maybe a bit of a trivial example, but let me show you how you can run into issues and how this can be helpful to know. Let's go to our company model. And there's this feature in Laravel that I'm not a huge fan of, but I see it used. And I'll just kind of show you why I don't like it and kind of how this can help illustrate this problem. So let's go to the company model and then let's add a new protected with property, and we're going to set that to users. And what this tells Laravel is to automatically load anytime a company model is loaded, to automatically eager load the users for that model. So if you think about it, on this page here, we're loading all the users and then we're eager loading the companies for them. So what this is going to then say is, well, then once you've loaded those companies, then also load all the users for those companies. And obviously this doesn't make a lot of sense for this particular page. And the reality is this quite often doesn't make sense, which is why I'm not a big fan of it, but it still will illustrate the problem here. So if I hit refresh here, you can see that this page, nothing much has changed. And if we look at our memory usage, we've gone from 4 megabytes to 6 megabytes, which like hardly raises any alarm bells, at least not for me. It's like barely a noticeable change. But what's interesting is we went from 32 models to 832 models. And that's because now for every single one of these companies, we're automatically eager loading. If we look at our queries here, we're automatically eager loading all the users for all the companies. And every one of these companies has 50 users, which is why we're getting 800 more records. So that's just like a really simple example, but it's super, super helpful if you enable this feature in the Laravel debug bar in your apps and just browse around a few different pages and see how many models are being loaded. It might surprise you. And if you see that there's like tons, like I had someone just today tell me they had like 23,000 models loaded on their page. That's not good. That's a lot of data coming back from the database. And in all likelihood, probably don't need all 23,000. So it helps just identify issues, and it's kind of points you to a problem that you can then go and figure out. Okay, so let's remove this. Again, I'm not a big fan of this feature. I think you're better off just manually eager loading from your controller or more from the perimeter of your application. This is much too specific, too deep within the app for it to be concerned about eager loading a relationship, in my opinion. Okay, so that's memory and models.
Jonathan,
Yeah.
we have a couple of questions from back when you were talking about the indexes, if you don't mind.
Mm-hmm.
Okay, so one of the questions was, if you had a third field you were sorting by, would you add a compound key for each possible combination?
Yeah, like you would, absolutely. And that's where it kind of becomes a little bit hairy. What I also didn't mention is like depending on the way you do your sorting, your direction. So you could sort one ascending, the next one descending, and the next one ascending. You literally have to make the index. MySQL has this new feature as a MySQL 8, which is descending indexes, I think they're called. So you can actually tell MySQL that you want to create the index specifically for a descending. So that's something else you need to keep in mind as well. But yeah, I think for myself, I often had this idea that indexes are just this thing that you add. You know, I'm going to create a users table and then I'm going to throw an index on the first name, the last name, maybe the email, maybe the company ID, whatever. And magically throughout my application, things are just going to get faster. But the reality is that's very much not the case. You might get lucky and you might make it faster, But indexes are much more something that you say, I need to, you look at the queries your application's running, the very specific queries it's running, and then you create indexes tailored to those very specific queries. So as opposed to let's create some indexes and then run some queries, it's more like don't create any indexes, write your queries, see exactly what your application needs, and then create the indexes for those queries. And that was a real like change in thinking for me. But it's really, really a helpful way to look at it, because the reality is the other way just doesn't work. Adding all kinds of indexes that don't even get used by your queries literally only hurts the performance of your database, because you're adding data unnecessarily that may not even be used. Because every time you create an index, there's a cost to it, both in storage and then also just in the time to every time you update a record or edit a record or delete a record, work has to be done to re-update those indexes. So there's a cost to it as well. So if you, for example, had a page with 3 columns, or if you just had a page with 2 columns that you wanted to sort ascending or descending in different ways, you might actually have to create multiple indexes tailored to each specific query. And that's where, like I was talking to someone on Twitter about this today, it really becomes a trade-off. You got to kind of analyze it and say, okay, well, 99% of the time, our users are going to be sorting this way. So we're going to create an index for that. And every once in a while, they may run the sort in the opposite direction. Well, in that case, maybe we won't create an index for it, because it's not used enough to justify the existence of that index.
Mhm. All right, thank you. You kind of answered the following question that we actually had, so I'm just going to mention it here, just so whoever asked it doesn't feel left out. But they were curious about what were the downsides of making indexes, and is it just a matter of storage space? And I think you've done a very good job of answering that.
Yeah, those two things for sure. And it depends on your project too, right? Like my web app that I run has, at the most, the odd table has a few million records in it. And when you're dealing with data kind of that size, you're not paying a huge penalty, right, for those indexes, because your database isn't even really that big. But the problem becomes when you start to get a database that has millions and millions and millions of records, where even just adding an index is a terrifying thing, because it can take so long to build up that index that you got to start becoming smart with how you deploy that index. That's when it really starts to matter. So kind of as the database gets bigger, that's where your indexes and kind of the cost of having the index becomes greater and greater. Like there's been web services, I can't think of the one, I want to say Stripe, but I'm not sure if it was Stripe, but there was a service that literally took the whole service down because somebody deployed an index that took like hours, maybe even longer to build the index. So yeah.
I gotta remember that. So there's one final question.
Yeah.
And then I think we can move on. Any tips or tooling for helping to identify queries being run in production that could benefit from adding indexes?
Yeah, absolutely. So there's a bunch of stuff out there. Yeah, I can remember some of them. So like I use Heroku, for instance. Let me just see if I can log into my Heroku account here for a sec for my app. And if I go in here and I go to my database, Postgres, and if I go over and stand by, let this load. And then if I look in diagnose, maybe. Yeah. So this is one tool here, which is really handy. So this will like help identify any issues. This is in particular, most time consuming is really interesting. So it shows you all the queries in your application and how long they're taking, and different metrics along that. So a really good one to look at is most time consuming and most frequently invoked as well, as another good one. So Heroku, if you're using Postgres, gives you these stats right out of the box, which is really, really handy, because it's not necessarily which ones are the slowest, and it's not necessarily which ones run the most. It can be the combination of both. It's which ones are taking the most time overall, because those are your most expensive queries, and those are the ones that are putting the most load on your system. So that's one tool. And then I'm trying to remember, there's a super, super common application like server monitoring service. New Relic, that's the one I'm thinking. So we've used New Relic in the past, and that works great as well. It'll keep really close eye on your database queries, and you can kind of figure all that stuff out as well. Now there is a cost to running New Relic. There is like a cost to the server, but if you're trying to learn, even if you just run it for for like a week or two to just kind of say, well, which queries are costing us the most? That can be another really good service to use. And there's others, like it's not, New Relic's not the only one. So that's what we did. When I was talking earlier about how we had these fast queries running, but all this data, that I was actually using New Relic back in the day to kind of figure that out. Cool.
Awesome. Thank you very much.
Okay, moving on here. So we've updated this to sort by the name. Something I think is always interesting is to sort how to go about sorting by the company name. So we're using a belongs to here, belongs to relationship for the company. So it's actually not that hard to sort by the company name. So the simplest way to do this is just with a join. So we'll do companies, join companies where the companies.id equals the users.company ID. And then what I'm going to do is I'm going to select users.star. And the reason why I do that is because Laravel by default, anytime you join in a table, it's going to automatically select both your primary table, which is the users table in this situation, and the companies, all the columns from both the company and the users tables. So I just want the users columns. And then we can just do an order by here. So order by, let's see if I can type, companies.name. And now if we hit refresh here, you can see that we're now sorting by the company name. Select users.star from users, join in the companies, order by the company name ascending. So that's really quite simple. And with a belongs to, it is really quite simple. There's another way you can actually do this too. You can use a subquery to do this. So you can say order by, and this was as of Laravel 6 maybe is when this got added. And you can say company, and I'll just import that. And you can say select the name and then say where the companies.id again equals the users.company ID. All right. And so what this is going to do is this going to run this as a subquery of the order by. I'll show you kind of how this works here. Hit refresh and we get the exact same results. Although it does change because we're not sorting by the username or anything. So the results are slightly changed, but it's still sorting by the company in the same way. So if you look at this, and I'll just paste this into editor here and set and wrap and make this a little bit bigger. Oops. Here we go. So select star from users, order by, and then it's running this as a subquery. Select name from the company's table where the company ID equals the user's company ID. So this runs as a subquery. And this is, in this particular situation, this is actually a worse solution because before it was running, actually, what are we at here? Yeah, we're at about 2 milliseconds. So it's actually the exact same speed as doing it the other way. So there's often this argument about, what's faster, joins or subqueries. Well, databases are actually quite good running subqueries nowadays. Joins in the past have been faster, but subqueries have become, databases know how to behind the scenes optimize them to run, really, really fast as well. So that's just kind of like an alternative way of writing that same code. So I kind of like the subquery approach because it feels like super readable to me and you don't have these joins and column issues, but it's something to keep in mind. And depending on what kind of relationship you're doing, you're going to have to write it in different ways. I actually have a blog post that I just put out on my website under ordering database queries by relationship columns in Laravel. So I cover has one, belongs to relationships, has many relationships, and belongs to many relationships. The has many relationships and the belongs to relationships are quite interesting and quite challenging. I kind of explain all that. And it's also in my course as well. I just think it's a really good thing to know how to do because I find you end up trying to order by relationships more often. And there's not like this nice, simple way built into Laravel to do this. You kind of got to know about the join approach or this subquery approach. Now let's do one more order by. Okay, let's order by the birthday this time. So note here that this is a birthday, not birth date. So we don't want to order by the oldest person to the youngest person or vice versa. We want to order it by the person has a birthday in January 1st, all the way to someone who has a birthday in December 31st. And this is kind of a fun one because it makes it a little bit more tricky and you got to run an expression to do this. So let's give this a try. Let's get rid of this. And what we're going to do, so we're not going to, like I said, we're not going to do order by birth date here, okay? Because that would give us the oldest people, not the people with the birthdays in January 1st. So instead, we're going to do order by raw, and we're going to pass through an expression, and we're going to do date format, and then we're going to pass through the column birth date first, And then what we're going to do is we're just going to pull out of that the month and the day. So we're going to leave the year out of it entirely. Okay. And that's really all we need. So we're just getting, so imagine this is going to be like for June 2nd, it would be 06-02. So as opposed to 2001-06-02. Okay. So now if we run this here, we can see, well, we can't see, but it is working. And the reason why we can't see this is because MySQL by default, when sorting ascending, shows null values first, which I think is not very helpful, but that is in fact the way MySQL works. So if we jump here to, we got 10,000 users. So let's jump to page 500 here. So you can see there we have January 11th, 12th. So we can see that it's working. Okay. But we got to deal with this little issue here. And the other issue that I want to look at here is just how fast this query is running. So this one's running at 28 milliseconds, which isn't bad. But again, I always like to, push the limits and see if it can be done faster. So if this was, again, it's about trade-offs. Is this an important query in your database or in your application that runs all the time? Then maybe 28 seconds is too long. If it's something that's an outlier that doesn't run frequently, maybe 28 seconds is fine. So let's go and let's make this faster again by adding an index to this. And you'll find that a lot of my talk around database performance has to do with indexes. They're just such a powerful thing, and they just make such a big difference on performance. And I find them like the most challenging thing to kind of get my head wrapped around too. Like it's taken me a long time to just understand indexes. It feels sometimes like a bit of a black art. And the way I've done it is a lot of times it's just I'll paste a query into Table Plus and I'll run and explain. I'll hack on it, try to add an index, try to remove an index, see what works, which is obviously a slow process that I'm trying to help you guys avoid some of that by showing you some tricks here tonight. But yeah, indexes, they're a worthwhile skill to learn, but a bit of a tricky skill to learn. Okay, so let's add this index. Go back to the command line here, and we're going to say PHP artisan make migration. And then what we're going to do is we're going to add a birthday index to users. And now we'll go to our birthday index. And I think I'm going to close this one up here. And we need to add the index. Now, previously, prior to Laravel 7.7, if you wanted to add an index that runs as an expression, you would have to do this yourself using DB statement. But don't need to worry about that because in Laravel 7.7, I helped get a new blueprint method added, which is called raw index. So this allows you to run a raw index and include an expression within that index. So if you tried, for example, to just use a regular index here and put an expression in it, so let's grab our expression. Let's just try that out here. And if you were to try to run that, PHP artisan migrate, it would blow up. And the reason why is it says, basically, there's an error. This whole expression doesn't exist. So it's looking at this expression as if it's like a column on the user's table. So we can't do that. So let's get rid of that. And let's just do a raw index. And then we'll just paste that in there like that. We're going to wrap it in brackets because it needs to be wrapped in a bracket to tell the database that it's an expression. And then the only thing that we need to do in addition to that is we need to give it a name. Now, normally when you create an index in Laravel, Laravel automatically basically comes up with an index name for you based on the columns in the table. But Laravel is not going to know what to call this. So we have to give it a name for this column. And what we'll do is we'll just call it the user's birthday index. And then we'll just also add the down migration as well. I don't think we're actually going to need this one for tonight, but we'll just remove it or add it just in case. Okay, so again, raw index, we're going to put in the expression that we put in our database query right here. And then we're assigning it, we're giving it the name user's birthday index. Okay, now let's go over, let's rerun that migration. This time it worked. And now if we go over to the browser again, hit refresh, you can see that we're now back to running 1.89 milliseconds, so less than 2 milliseconds. So the thing to keep in mind here is when you create an index for an expression, the expression that you run in your database query must match the expression exactly as it is in your index. Otherwise, it won't work. So that's why you couldn't now suddenly change this to, some other value, that wouldn't work. Those values have to match up exactly in order for this to work. So that's a nice little way that if you're running some sort of an expression that's running slowly, you can create an index with the expression, and basically behind the scenes, MySQL is building up this table of that value, whatever the computed value from this date format function, And then when we run this query, it's using that to do the ordering instead of just calculating it on the fly. I still want to address this whole null first issue. For any of you who are using Postgres, I love Postgres, but I also love MySQL, but they're both good. You can do this really cool thing when you're doing an order by where you actually say nulls last. And then when this query runs, it'll automatically put the null values last. And you don't have to worry about this at all. That's a really nice feature of Postgres if you're using it. Unfortunately, we don't have the ability to do that in MySQL, so we need to come up with another way of doing that. And there actually is a fairly straightforward way to do it. You can say order by raw again, and we're going to run an expression again. And what we're going to do is we're going to just say, is the birth date null? Birth date is null. And what happens here is this is going to run and it's going to calculate out to either be true or false. And if it's true, it shows up first because when MySQL orders a Boolean, true values show up before false values. Okay, so let's just run this now and hit refresh. And you can see, sure enough, we're now getting January 1st. Our null values are listed secondly. However, if we look at our speed here now, we're back up to 32 milliseconds. So it's like, database indexes are these just horribly brittle things. And you have your index working, you have things running super fast, and you make one little change like this, and now your index is out the window. So this is this is all part of making database queries fast and making your applications fast. You kind of learn this like bit of a struggle. Like I think of like that Homer Simpson's GIF where he's like trying to fix the blinds, and people use it all the time for CSS, right? To explain how hard CSS is. Honestly, that GIF is way better suited for database indexes and database queries because that's literally what it feels like. You're just constantly pushing and pulling, trying to figure out how to make these two things work together. So here we are, we broke this index. So we can fix this though. Remember earlier when we ordered by the name, the first name, the last name, when we ordered by two things, we needed to create a compound index in order to have it sort by two columns at a time. And we need to do the exact same thing here. The only difference is this time it's a little bit more complicated because our index in this situation has expressions. It's not just columns, it's expressions. But you can create a compound index with expressions. So we actually are going to have to roll this back. So that's a good thing. Okay, so let me just roll back here for a second. Okay, that's good. And now let me update this. We're going to say in here, and we're basically just going to literally paste in exactly this expression that we wrote here. And birth date is null, and then the rest of our index. Okay, now if we run that, hopefully that works, and we go back to our browser, hit refresh, we're at 32 milliseconds, and we're back down to less than 2 milliseconds. So I hope that gives you a bit of an idea of like what you can do with ordering and indexes and compound indexes and even expressions. There's a lot you can do to make these queries a lot faster. Again, it's not as simple as just creating a bunch of indexes on a bunch of columns. You really got to analyze what's the query that you're running and what's the most optimal index for that particular query. And again, I think it's a trade-off. You got to pick and choose. I don't think you want to create an index for every possible query. I think you want to pick the ones that matter the most, the ones that run the most frequent, the ones that are costing you the most, and kind of optimize those. All right. So the next thing I want to look at is I want to do some so pretty much at this point, we've mostly been dealing with selecting data, like getting the companies and ordering all these columns. I'd like to look at filtering a little bit. So let's go over to our user blade view here. And I have a form ready to go here, which is just a really simple search form. So hit refresh here, just add the search form to the page. What this does is if I search for something, it just passes. So let me just search for this first name and it just passes it through as a query string. Okay. So what we're going to do then is in our controller, we're just going to get rid of these order bys for now. We're not going to worry about the ordering anymore. And what we're going to do is we're just going to say when it's just this handy conditional thing that you can use within your query builder to just check if something's true. And if it is, then run some additional query builder logic. So what we're going to do is we're going to check to see if the search value exists in our request. And if it does, it's going to run whatever code we put into this callback. And the first thing it takes is an instance of the query builder. And the second thing is it takes the value, which is our search value. So let's think about how this is going to work. We're searching here. We got the first name and the last name in here. So what we want to do here is we want to check if the first name exists in either the first name or last name column. And then we want to check if the second value exists in the first name or last name column. So kind of just a quick and dirty solution here is we can just do for each, and we'll do an explode on using a space as our delimiter on the search value. And then we'll just call that a term. So basically what we're doing is just getting each of these words. So if we just dump this here for a second, so you can see, we're just getting the 2 different terms in an array here. And then what we'll do is we'll write a query for each one of those terms. So we'll do query where, and we're going to wrap this in a function in a closure here because we're going to use an or statement. So we need, anytime you use an or statement, pretty much anytime you use an or statement when you're writing a database query, you need a where closure that wraps it so that it puts parentheses around whatever you put inside of it. Okay, so then we'll give it a query and then we'll pass through our search term. And I'll spell that right. Okay. And then we're going to say query where the first name is like the search term, but we don't just want that. We want to put the wildcard symbol in for the like search and put the end wild so that it searches not only the beginning and that, or it doesn't have to be a perfect match. It can just be anywhere within that string. And then we'll say also just copy and paste this, or where the last name is like our search term. Okay. And now that all makes sense. I hope that makes sense. Just basically iterating through each term and checking to see if the first name matches that term or the last name matches that term. Okay, if I haven't messed this up and hit refresh, I messed it up. Somehow I messed it up. Okay, where did I mess it up? Like, oh, yep, I know why. I'm passing through search here. We need term, not the search. Let's do this again. There we go. Okay, we're getting our first record here. So select star from users where the first name is like our search term or the last name is like our first search term, and the first name is like our second term and the last name is like our second term. So more terms you have, the less results you'll get. So if we were to remove the first name here and just search for Larson, you can see that we're getting more results. And this is not a bad solution for a simple search, but if you know anything about the like operator, it's pretty simple pattern matching, and it's not super, like, it doesn't work great if you have spelling mistakes. It doesn't work if, I'm trying to think of a good, let me see if I can find a good use case here. Like if we were to search here for a company name that would be appropriate, okay, here's a good one. So say we have this name right here, and so you want to search for this, and you just remove the and you hit search. It's not going to find it because it needs to find the whole thing, right? So there's kind of like a bunch of problems with kind of that approach. But before I kind of get into exactly how to solve those, I just thought I'd also show you here. If I go back to where we were, I'm just going to rerun a search here. I just want to talk a little bit about the performance of this query. So it's running about 37 milliseconds. And kind of before we implement a better search here, I just wanted to show you a little thing that might be useful to know for your applications. You might think here, so let's just say that this search was appropriate for your app, and you're saying, well, why is it running at 37 milliseconds? It'd be nice for it to be a little bit faster than that. You might be inclined to add an index, kind of like we've been doing this whole time. So this time what I'm going to do, though, is I'm going to write a new index. So PHP artisan, make migration, add first name index. And I'll tell you why I'm only making a first name one in just a moment, okay? So let's go here, add first name index. And then here, you know what? Let me just delete that one and redo this. 2 users. Okay, now let's go to this thing. Yeah, okay, so when you do 2 users, Laravel's smart enough to notice 2 users, and it'll automatically scaffold the schema table for the users table in there for you. Okay, tangent. So let's go in here and say table index, and we're just doing on the first name, as I mentioned, okay? And we'll put the down one in here just to be consistent. Drop index users first name index. Okay, and now let's run the migration. PHP artisan migrate. Okay, and now if we go here and we hit refresh, surprise, surprise, it didn't make any difference. And the reason why isn't because we don't have the right indexes in place. It's actually a limitation of MySQL that's causing our indexes not to be used. So let me just copy and paste this query here. Let's go into Table Plus, and let's run an explain on this again. If we run this, we can see that it's using where here. So it's using where, which means it's not using our index. There's no indexes being used here. So let me just show you something here. Let's remove on all these like checks. Let's remove the leading wildcard symbol and let's run it again. And lo and behold, it's now using our indexes. MySQL is unable to use an index if you have a leading wildcard symbol. So the only way to use the index is to remove that. That is like a limitation of like pattern matching that you should be aware of. You just can't use it with an index. And the reason why is because if you think about how indexes work, it starts kind of at the start of the string. And you think of like a phone book that starts like A to Z, it's looking for the first letter in the A position, and it kind of works through systematically like that. But if the term is not guaranteed to start at the beginning of the index, then it's anywhere in the middle. And basically, MySQL has no way of like, cheating and jumping forward to where that value exists in the index. So that's why that doesn't work, but it does work at the end. So if we reload this now, we still get a result, and the query is now down to in and around 2-3 milliseconds. So that's just something to be aware of if you're using like. Now, you might know right off the bat that this creates a bit of a problem. If I were to remove the Z here from this and run this search, it will no longer work. Whereas if I had them in there, it would work. So that's something to be aware of. This is kind of the issue with using like and pattern matching to do searching like this, which is why people often reach for more sophisticated solutions, which is what I want to show you to kind of end this little presentation. So what we're going to do is we're going to use full text searching for this for a moment. So I'm going to get rid of all this jazz. And what we're going to do here instead is we're going to add a full text index to this. And typically in the past, with MySQL, I wouldn't recommend using full text indexes to do searching on like something as simple as a name like this. Typically, full text searching and full text indexes were better suited for like large documents. So like a whole, maybe a blog post or something like that that has a bunch of content in it. However, as of, I want to say MySQL 5.7, maybe 5.8. Was there 5.8? Yeah. They added n-gram support to full text searching in MySQL. And at least in my experience, it works really, really nice for kind of this fuzzy style searching. So let me just show you how easy this actually is to implement it. So let's do PHP Artisan, make migration. And the theme of the evening is adding an index. So this time we're going to add a full text index to users. Okay. And then I'll just open that up. And then here, so this is one situation where you can't use the fancy table raw index thing that we were doing earlier, because that doesn't work with full text indexes, because full text indexes are written a little bit differently. So we are going to have to use DB statement in this case instead, but that's okay. We can make that work. Not quite as pretty, but the end result is worth it. So let me show you how to write this. We're going to say create full text index, and then we're going to give it a name. So we're just going to call it users full text index. So that's just the index name. And then we say on, and then we have to give it a table to make that on. So we're going to say users. And then what we do is we have to give it the columns that we want to create the full text index on within their users table. And in this case, it's the first name and the last name. And if you're wondering, the order this time doesn't matter. Then we say with parser n-gram. So this n-gram thing is the thing I was mentioning before. That's a huge improvement, at least in my experience with full text searching. If you're familiar with trigrams in Postgres, I think it's very, very similar sort of thing. Okay, and then let me just check my notes here to make sure I've written that right. I think I have. And then we'll just add the down migration as we have been this whole time. So drop index, and then pass the name. Okay, so that's it. Now we run this migration, PHP Artisan migrate. Hopefully that works. Yep. And if we actually jump over to our table here in Table Plus, and we go to the users table and we hit refresh, we can see that Table Plus is nicely displaying this as a full text index. And that index has been created on the first name and the last name columns. Okay. With that in place, we can now update our database query. Really, this is all that's required to get the index set up. So let's do this. This is where it gets a little bit complicated, but I think once you kind of get your head wrapped around it, it's not too bad. I'm going to hide the side column here. Maybe make it a little bigger. Okay, so we're going to say query. And the first thing we're going to do here is we're going to select raw. and we're going to run a raw select, because what I want to do is I actually want to get a score from this search. So whenever we type in some keywords, each record is going to be assigned a score from the full text search. And I've already actually updated the user blade view. If there is a score, it actually outputs the score formatted nicely for us. So we haven't seen that to this point because that column hasn't existed. So we want to score just so we can kind of see how MySQL and how the full text searching is working. Okay, so what we're going to do is we're going to select raw star. And the reason why we select star there, we could also do users.star, is because when you run a select raw before running any other select statements, it will only select whatever you put in the select raw statement. So we know we want all the users columns, so that's why I include that. Okay, and then what we're going to do is we're going to say match. So match is like a full text searching function that you can run in the database. And then we're going to say first name, last name. So it's kind of similar to the way we wrote our index. At this time, it knows it's a table, so we don't need to give it the table name. And then we say against, and then we got to give it a value. And the value is we're going to pass it through as a binded parameter. So we're just going to put a question mark here because that's how you use binded parameters with Eloquent, which under the hood uses PDO and PHP. And then we're going to say in Boolean mode. So MySQL and full text searching has different modes. So there's another mode called, I think it's called natural language mode. I find that Boolean mode, at least from my experience, works better than the natural language mode. So that's what I use. And then we're just going to take this whole mess here, this whole match term, and we're just going to give it we're just going to alias it to a column name. And we're going to call that score as I mentioned. Okay, now with that in place, I'm going to copy this whole thing again. And you know what? Actually, let's just try run this first. What I need to also pass through the binded parameter, right? So we have this question mark here. So we are going to need our binded parameter, which is our search term. So notice this time, I'm not exploding the search term. So if we die and dump this search term here in our search, and you know what, I'll add the full name back. There's our search term. So that's exactly what we're passing as a binded parameter to our query. So now if we run this, if I haven't done this wrong, we're going to get, yeah, okay, so this is working. So we can see here that Zella here has a score of 10.96. Now, a whole bunch of other people have no score, no value assigned at all because they didn't match the search. So it's just null or zero. I'm not even sure. If we run this here, let's take a look at this query and run it in Table Plus. You can see here at the end here, now we have the score column. So you can see all these other users have zero for their score. Okay. So we're like, this is like step one, really. And then what we can do is, so now we have it calculating the score. Now we can filter out the ones that basically have a score of zero. So let's add that next. So we can basically run this exact same chunk of code, and we can say where raw. So we're going to use another raw query, and we're just going to say match. So this match statement returns zero or greater as a result, right? The score. So we can literally just run this. So if you run a where match statement like this, if it's zero, it's not going to include the user. If it's anything greater than zero, then it will. And then we just need to, again, include our binded parameter. And now if we hit refresh again, we can see that it's now working. We're now getting our sorting ordered by the relevance. So you can see all the Dibert ones here are matched. And the Zello one, because it's matching both columns, it's ranking the highest. And if we were to flip this around and put it the other way around, it still works. So the order doesn't matter. If we were to get rid of let me get rid of one of the B's here. Now so it's always a mystery how MySQL, the full text searching, orders it. And now it feels like this individual is higher than Dibert here, but it works pretty well. And it works, in my experience, a lot better than the like searching for kind of just sort of out of the box fuzzy searching. If you're using MySQL, it's really a quick and dirty way of getting really decent fuzzy searching implemented with minimal effort. I find a lot of times people, they go down this road, like searching doesn't solve, pattern matching doesn't solve their needs. And they quickly jump to using a tool like Algolia or Elasticsearch. And those are obviously amazing tools that have their use case. But sometimes it's just nice if you're using MySQL or Postgres to just use some of this built-in functionality, because it can get you really far without kind of all the cost of using Algolia or Elasticsearch and kind of like that whole orchestration of, making those two things work together. Okay, so in this sort of situation, it's super common to want to also search, like on a page like this, also search by a company name. And you can absolutely do that with the full text searching as well. And I'll just show you kind of like a neat little way to implement this. So the challenge is, if we look back at our index where we created our index, let me get back to that. We can only create a full text index for the columns of a single table at a time. So we can only create the first and last name indexes on the user's table. We can't like magically like join in here, at least not that I know of. So if anybody knows better, I'm 99.99% sure this is true. We can't add in like the company's table some here and write some sort of subquery to pull in the company name. So if we wanted to create a full text search for the company name, we need to somehow create a full text search index on the users table and then a subsequent one on the companies table. And then in our query, figure out a way to merge the two together. So let's do that. So we're going to say PHP artisan make migration, and we're going to say add full text index to companies. Okay. And we go there now. And I'm just going to copy this because you guys don't need to see me rewrite it, because it's going to be the same. Except this one, it's not going to be users. It's going to be companies, and it's not going to be first name and last name. It's just going to be name. Right. And then down here, same dealio. Table, drop index. Okay. So now that should be right. Create full text index, companies, full text index on companies, name. Yeah. Okay. And PHP artisan migrate. And spelled it wrong, obviously. Okay, there we go. All right. So now we have a full text index on both of the tables. So now we need a way to somehow figure out how to pull the two together and somehow do the ranking against both of the tables at the same time. So this is gonna get kind of fun here. Let me just take a peek at my notes here to make sure I don't mess this up. Okay, so what we're gonna do here, so we're gonna start with the raw statement here, and I'm just gonna do a line return here to kind of make this a little bit more legible. So we're gonna say, okay, we want the users.star, and then we're gonna do some math score. Yeah, okay, so we're gonna say users.star, and then we're gonna do a little calculation here. And all we're gonna do is we're gonna say, we're going to get the match against the users table, the full text match against the users table. And then we're going to add the score from that with the score from the companies dot name table. So from the companies table, and we're going to run it against the exact same search term, right? So we need to remember to add the search term twice here because we need it twice within our query. Okay. So the only thing you'll know right away is like, well, where is this coming from? Well, we need to join it in. We need to join in the companies table. So we'll join companies where the companies, I think my typing is getting worse the longer I go here, matches the users.company ID. So now we're going to get the score. Yeah, we'll get the combined score of the two. Then what we need to do is we need to update the where statement. But the thing about the where statement, we can't just do this, which you might be inclined to do. And we'll just replace this first name. We'll change this to companies.name against the Boolean mode. So we can't just do this. And the reason why we can't is because this is going to mean that every single search that we run has to match both the users table and the companies table, which we don't want. We want to be able to run a search for, whatever name and have it match. We want to be able to run Zella and just get Zella, even though there's no match in the companies table. So what we need here is we need an or statement, which we can use again, an or. We need a closure. So let's add that. That's going to take the query. We're going to use the search term, and then we'll just take these two where statements, query, and then we'll just do or. So this is the important change here. We're going to do where it matches either the first name and the last name in the users table, or where it matches the company name in the companies table. And I need a semicolon somewhere. There we go. Okay, I think that's right. Okay, moment of truth here. So we're going to do Zella. We're going to search for this, and we're going to include the name, the company name here. And that doesn't appear to have worked. See what I've done wrong here. As score, let me double check. my math here. Maybe I've just chosen a bad example. Let me try this first. Let me just see if I can get company names. Feels like it's working. Oh, I know it's wrong. I know it's wrong. We need to, so yeah, so how do I explain this? By default, when you calculate the score against a single match, MySQL, you might be wondering, well, how did it know what order to sort them in? Um, MySQL will automatically, if you do a single select statement on a match, it'll automatically order by that score. That's just like a magical thing that MySQL just does if you do a single match. But because we're doing a double match here and doing some math, it no longer automatically searches by the score. So what we actually need to add down here is an order by descending search by the score. I almost felt like it probably would have been better for me to just have put that in right from the get-go. But yeah, I meant to kind of mention that MySQL will automatically sort by the score if you do a single match, but not if you do two. So now let's hit reload here. And now hopefully we go back to that search. There we go. Okay, it's not the right search. Let me try this again here. I'm hoping that we get this one first now. And sure enough, we do. Okay, so Zella, what like these names? Faker, work with me here. I'm not good at pronouncing complicated names. Zemlak here. So you can see it's 30, score of 30, and the next one down. So if we now were to modify this, so let's just search by Kohler only here. You can see that we're still getting this, but it's now down to 23.73. And if we search for just Zemlak here, it's still down, it's 24. But if we just search for Kohler, now we're getting Kohler. So now like it's searching both columns. It's combining the score from the two columns and ordering it by that. So this is like a really, really powerful way of creating a fuzzy search with really, yeah, it's not the prettiest code you've ever seen, but wrap that up in a scope, throw it in the model, and create a nice little search scope. And it's really not a big deal because it works really, really well. And it's fairly performant. It's running around 50, 60 milliseconds, which is much higher than the other queries that we're running. But this is a much, much more complicated query. It's doing a full text search against 3 columns across 2 different tables. And if I can run that in 50, 60 milliseconds, that makes me very happy. So yeah, that's how you can do simple full text searching with ngram. Definitely look if you haven't worked with it before, check out the ngram parser because I find that it just works so much better for this kind of searching. All right, that's all I had.
That's great. Wow. Thank you so much. Thank you so much. Jonathan, we do have a few other questions. I'm going to go in most recent first because there's a couple from back when, and we're going to keep things hopefully so we don't have to page information in and out. Okay, so I don't actually understand this, but that's why you're the expert and I'm not. This might be more of a comment than a question, but I'm not sure. So here we go. Loved the tips! Exclamation, exclamation, exclamation. Limit x+1 for pagination detection. 2 table name, suffix, on migrations, fuzzy full text ngram ID is my own DB instead of external. Oh, I think that's a comment. I think that's basically, hey, you blew my mind, man. Thank you so much. That was great. Can't wait to get your course. Amazing. Moving on from there.
Thanks for the feedback. Glad you enjoyed it.
We've got, is there a plan to add full text indexes and match queries to Eloquent in the future?
Yeah, like I've thought about it, like just to make basically, yeah, so it's always a hard thing. Anytime you try to abstract something, you want to abstract it in a way that it's helpful, but also doesn't completely limit the tool, to the most basic sort of use cases. So you can just see here tonight, like you could easily have created some sort of match helper, right, in Laravel, but immediately, like even just in this simple example here, a single match helper wouldn't have done it. We want to match against 2 tables, and then we're using some math to add the 2 together. So I don't know. I've been debating it. I kind of have a whole list of ideas that I want to kind of bring back and contribute back to Eloquent. I have already, contributed a bunch of ideas, such in the past, such as some of the subquery support and the raw index and a few other things. So maybe I think at minimum, I'd love to see a better way of doing just something built into the migration blueprint that makes it easier to create a full text index for MySQL, and ideally something that would have some sort of cross database capability with Postgres. So the short answer is I love the idea. The long answer is I'm going to do it only if I find time and if I can find a nice way to create an abstraction.
All right. Thank you. We have another question here. Do eloquent query scopes slow down the database selects?
No, like I want clarification that you mean when you say scope, do you mean like model scopes? I'm assuming that's what they mean
Yeah.
when I hear that. So definitely not. Now, anytime you add, another layer to the application, it could make it slower. But let's just do that here real quick. So I make scopes all the time because I love scopes. Public function scope, search, and that takes an instance of the query builder, and it'll take us instance of our search term. And then what we can do is we just grab this whole mess and paste that in here. And then we can just in here say query search. And if I haven't screwed this up, look, that should work. Yep. Hit refresh here. It still works. And so is that slower? Does that cause the page to load any slower? If it did, so back it up here. So we're at 82 milliseconds, 83. Like it's minimal, like nothing that would actually be noticeable. So I love using model scopes like this to wrap up query builder logic. It just makes your queries and your controllers so much nicer, and it's much more reusable that way as well.
All right, thank you. And then, so one other question, and I believe this goes back to when we were talking about ways of profiling your application to find out where the slow queries exist. Can
Yep.
we use Laravel Telescope in production for checking requests and queries?
Yes. Yep. You sure can. Yeah. So Telescope was designed in such a way that you can, because Telescope. So for anybody who's not aware of it, if you go to the Laravel documentation and you go under the official packages, one of the packages that Laravel provides, Laravel Telescope is this really great little package that they put out that allows you to, it provides a lot of the same functionality as the Laravel debug bar, but it runs as like a little separate control panel, kind of a min only control panel. So if you're familiar with like Laravel Horizon, it's the exact same sort of concept. So yeah, Telescope, because it's not like right in your face in the application like the Laravel debug bar, but it kind of this backdoor thing that only admins have access to, you can run it in production. And it's been designed that you are able to run it in production to help identify these kind of issues. So you know where else this is actually really, really helpful that I probably should have mentioned is the Laravel debug bar works awesome if you got pages that are rendered with Blade. But if you have an SPA that's making API queries, you can use it in that situation because Laravel debug bar will like track XHR AJAX requests as well. But sometimes that becomes a bit of a nuisance. So if you're working with like an API, or maybe you don't even have a front end and you're just testing the API, Laravel Telescope is really helpful as well for those situations where you don't have the ability to kind of do what Laravel debug bar does here.
All right, so that wraps up our questions. So again, Jonathan, I want to thank you very much. That was wild. That was great. I think that officially ends our GPUG. Again, I want to thank you, Jonathan, for giving the excellent presentation. I want to thank Vehicle, our sponsors, so Vehicle and JetBrains, for sponsoring the meetup. We couldn't do it without you.
Great job, Jonathan.
Hey, thanks everyone.
It was awesome. Thank you.